Okay. All right. So let's look at some problems. Here we have seen this already, but they gave this to you as a homework where the coefficient of friction is mu. But when there is no mu, the question was determine the height h from where this should be dropped, released, not dropped, released, such that it should complete the circle. It should loop the loop. It should completely, it should complete the circle. This For it to complete the circle, its tension should become, normal reaction should become zero here. Or tension should become zero here. So velocity doesn't become zero here because it's a string. String or normal reaction is being responsible for it to make a turn. Normal reaction cannot be negative, so it can be zero. When it is zero here, it means it cannot be zero anywhere here. All right. So what do we do? Whatever the energy over here, I conserve energy from here to here. I know the velocity over here should be greater than root 5 gr, where r is the radius of the circle loop. So mgh taking this as my reference is equal to half m root 5 gr square. M gets cancelled out. H naught is equal to 5 gr by 2. Sorry, g also gets cancelled out. 5 by 2, 5 r by 2. So my h from where that should be left is not 2r, but 5 r by 2, 2.5 r. So is it clear, students? Is this clear? All right, let me know yes or no in the chat box or unmute yourself and speak.
Yes, sir.
Okay. Okay. Now, we've done the similar case as well. Similar case where we had a spring. Now, instead of a wall here and a inclined plane like this, I had a spring at a horizontal level. This is a block of mass m compressed to an extent of delta x. I have to determine delta x such that this block should loop the loop, or this particle should loop the loop, should complete the circle. That means its normal reaction should not become zero anywhere except in the worst case over here. If normal reaction doesn't become zero here, it will never become zero anywhere else. Okay. Now what do I do? Now can you write the equation? Can you help me write the equation, students? Can you help me write the equation? When I compress it by delta x, what is the potential energy stored in it? Spring potential energy. So it is spring potential energy, which is half k delta x square. Now this should be equal to the kinetic energy over there with the speed of root 5 gr. Half m root 5 gr square. Do you all agree with this? Ha ya na?
Yes, sir.
All right. So I'll get delta x to be something. From here you'll get delta x. Half gets cancelled out. So delta x is equal to 5 mgr by k under root. Now what I do, I slightly change the scenario. I say from here to here for a length L, there is friction coefficient mu. This is K naught. Spring constant is K naught. Friction coefficient is mu. Now, how do I write the equation? There is no loss of energy till it reaches an equilibrium position. But from equilibrium position to this point, lowermost point, there is friction. So what do I do? Half K delta x square is the initial energy. Then what happens? There is a loss in energy. Loss because of friction. So minus work done by friction. How much is lost by friction? Something. That remaining part is resulting in kinetic energy, which is half m root 5 gr square. Why am I substituting root 5 gr every time? Because we have derived this that root 5 gr is a velocity for it to completely loop the loop. Minimum velocity for it to loop the loop is root 5 gr. So velocity should be greater than or equal to root 5 gr. So what is the loss due to friction? Mu mg L. That's it. Solve for delta x. That's the answer. See, it could also be possible that the particle stops somewhere here in between itself. But once it crosses this, it has to loop the loop. So one condition is it has to cross this. That means this has to be greater than zero. It should not just be greater than zero, but it should be greater than this kinetic energy. Only then it will loop the loop. If it is just greater than zero, it may just go till here and stop and come back. So it will come back on this path and stop somewhere here. Right. But for it to completely loop the loop, it should not just continue to move from here, but move with a minimum speed of root 5 gr. Is it okay?
Yes, sir.
Now, let us say if I have here also you have got friction, then what do I do? This natural from equilibrium position to this lowermost point, length is L, but friction is from here, delta x. As I compress from here itself, I'll have friction mu throughout. Then how do I write the equation? So what is the change in the equation now? If you can tell me some change in the equation, I'll send a derivative celebration packet to your home. All right, let us celebrate. But tell me the changes in this equation.
So
Yeah,
frictional force will be changes, sir.
sorry.
Frictional force.
Yeah, frictional
Frictional
force.
force will change, sir.
Yes, very good. ఎక్కడ చేంజ్ అవుతుంది ఎక్కడ చేంజ్
Mu
చేయాలి నేను
mu mg L plus delta x.
పర్ఫెక్ట్ వెరీ గుడ్ అడ్రస్ చెప్తావా అడ్రస్ చెప్పు నేను పంపిస్తా డైరీ మిల్క్ సెలబ్రేషన్స్ ప్యాకెట్ పంపిస్తా బికాజ్ యూ టోల్డ్ మీ ద కరెక్ట్ ఆన్సర్ ఎక్సలెంట్ దట్స్ ఓన్లీ చేంజ్ ఇన్ దిస్ ఈక్వేషన్ రైట్ దట్స్ ఓన్లీ చేంజ్ ఇన్ ద ఈక్వేషన్ దట్స్ అబ్సల్యూట్లీ రైట్ బట్ నౌ let us say instead of this scenario I've got spring scenario spring and also block is going right from here to here and then it has to loop the loop. This height is h. compression is delta x. Now, how do I write the equation? For me, this should have sufficient compression. Will this compression be more than before or less than before? This should have sufficient compression so as to climb the hill first. It should not just climb the hill, but once it reaches this plateau, it should reach this with certain velocity which is greater than or equal to root 5 gr. So how do I write the equation? So initial energy is half k delta x square. This is the initial energy. What is the final energy over here? That should be equal to mg into h naught plus half m root 5 gr square. Is this equation understood? That's it. That's the physics of the problem. Rest is just simple math. You have to manipulate and get delta x. Right? Make delta x the subject of the equation. But is the equation understood? Let's say this is also equal to r. So mg times r plus half mg times 5 gr. So I'll have half k delta x square is equal to 7 mgr by 2. Half gets cancelled out. Delta x is equal to root 7 mgr by k. Look at this. It is more than before now because I have to also spend energy in climbing the hill. ఇంతకుముందు స్మూత్ ఉండే హారిజాంటల్ ఫ్లోర్ ఉండే that time it was not a problem. But now I also have to climb the hill, not just reach this point with the sufficient kinetic energy, but I should reach that point after spending this energy in the climbing the hill. So కొంచెం ఎక్స్ట్రా ఉండాలి నాకు కొంచెం ఇంతకు ముందు డెల్టా ఎక్స్ 1 ఉంటే ఇప్పుడు డెల్టా ఎక్స్ 2 ఉండాలి డెల్టా ఎక్స్ 2 షుడ్ బి గ్రేటర్ దెన్ డెల్టా ఎక్స్ 1. All right, so that makes sense, right? Okay, so I hope this is clear. Okay, can I erase it? Okay, now let's understand one thing. I've got this dependent on G, right? Root 5 gr is depending on G. Root 4 gr, root 5 gr, root 2 gr depending on G effective. That means if I have got a loop like this and a particle here, and this is going in a effective acceleration G effective in a loop G effective, with an acceleration A naught, then G effective inside this loop for this loop will be G plus A naught. So my effective acceleration on this will be G plus A naught. I mean effective gravitational force plus pseudo force. With respect to this one, I'll have pseudo force as well, which is M A naught. So, but effective force is M into G plus A naught. Now, your velocity will now be not root 5 gr, but root of 5 of G plus A into gr. Root of G plus A into 5r. Root of 5 of G plus A into r. Because this is nothing but G effective. It is not just G, but it's G effective. Understand that. If I take this downward with an acceleration g, with some acceleration a naught downwards, so it'll have g minus a root gr for it to complete the loop. All right. Now let us say its acceleration is towards right. This is very important, students. Let's say its acceleration is towards right with g. So my effective g will be, effective acceleration is make an angle of 45 degrees with the vertical. Now this becomes my lowermost point and this becomes my uppermost point. All right. If I draw the analogy between this one and the on that which is on ground, this is in a car which is going towards right with g. This becomes the lowermost point. This becomes the highermost point. So now my minimum velocity should be v naught should be equal to root of 5 times g root 2 into r, or g effective into r, which should be at this point, not at this point. All right, not at this point, but this point. And if at all it is losing contact, it will lose contact somewhere here. And if it doesn't lose contact here, it will never lose contact anywhere else. That is my peak point now. That's the topmost point. It is not tilted. My universe is completely tilted. All right. I hope this is clear. All right. Now let's frame a question. I've got, all right, that is one question, that what should be minimum velocity v naught for it to loop the loop? Minimum velocity should be root 5 g effective into r at the bottommost point. So at the bottommost point in the sense, it is this point. At the point at which the normal reaction or tension is maximum. That's the bottommost point. As this goes away from here, my normal reaction goes on decreasing and it can become zero at this in this region. And if it doesn't become zero anywhere here, it will never zero. It will not become zero anywhere else. Or any doubt here?
No, sir.
All right. I lost track of something. Wait, let me just frame a question. Okay. Now I'm going with an acceleration of uh, g root 3 towards right. Now, what should be the minimum speed over here such that it should loop the loop? For it to loop the loop, what should be the minimum speed with which the particle should be projected at the point, at that bottommost point, if for it to loop the loop? Now, if it was g, it was at 45 degrees. Now it's g root 3. So the angle would be something else, somewhere else. And what that angle would be? Yeah, the angle now would be about g root 3 this way, g this way. At an angle of 60 degrees with the vertical. Now that's the direction of my G effective. Why is it so? Because G root 3 leftward, G downward. So the resultant of these two is, how much is the resultant of these two students? What is the resultant of G root 3 and G at an angle of 90 degrees? How will you find the resultant of these two vectors? What is the resultant of these two students?
Root 3, sir.
Resultant of root 3, G root 3 and G at an angle of 90 degrees. What is the resultant of these two vectors at an angle of 90 degrees? They are perpendicular to each other. What is the resultant of two vectors? Why are you taking so much of time? One vector
4G
is
square,
G.
sir.
Sorry?
4G square, sir.
No. No, 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 no. Think again. You are missing the root, under root.
Yes, sir. Under root 4G.
Yes, sir.
Under root 2G,
Sir,
sir.
it's 2G, sir.
2G. So its effective acceleration is 2G at an angle of 60 degrees with the vertical. Why is it 60 degrees? You understood from this diagram, right? Now, this becomes my bottommost point. నేను ఇక్కడ నుంచి ప్రొజెక్ట్ చేస్తే ఇది మొత్తం లూప్ చేయాలంటే it should cross this point, not this point. It is not sufficient for it to cross this point. For it to loop the loop, it should cross the peak topmost point. Topmost point is along the effective acceleration. Effective acceleration diagonal unte, then the topmost point will be this one. If the effective acceleration is G under gravity and on Earth, on ground, this is my topmost point. Right? Effective acceleration is intersecting this circle at 2 points. This point and this point. This point is the topmost point, this point is bottommost point. So when the effective acceleration is at an angle of 60 degrees with the vertical, this is my bottommost point, this is the topmost point, and velocity at this point, or speed at this point for it to loop the loop. Velocity at the bottommost point for it to loop the loop would be root of 5 G effective into R, which is nothing but root 10 GR. Is this okay?
Yes, sir.
Now tell me the answer for it is, what if it is G by root 3? Quick, then we'll go for the next one. What if the acceleration is G by root 3? What is the effective acceleration angle? And also, tell me the minimum speed for it to loop the loop. And when it is just looping the loop, what is the normal reaction over here is what I'm asking. All right, that's also a question. When it is just looping the loop, normal reaction over here is 0. What is the normal reaction over here?
Sir, can you repeat the question?
First question is G by root 3. Find out same parameters. Find out the angle of effective acceleration. Find out the speed at which
Sir, it's 30 degrees, sir.
30 degrees. Yeah, that's right. 30 degrees. Great. Next, find out the speed with which it should be projected at the bottommost point for it to loop the loop. For it to loop the loop, it should cross this point, not this point. Right? This becomes my topmost point now. Okay, so what is the answer now? What is the velocity or what is the speed with which it should be projected at the bottommost point? See, this is actually the bottommost point, but I'm telling you bottommost point with respect to this acceleration vector is this one. So it will have maximum speed here and minimum speed here. So what is the maximum speed at this point for which this should loop the loop? For it to loop the loop, what is the minimum speed required? Minimum speed required is root 5 gr. 5 g effective times r. What is g effective now? When it is g by root 3. What is g effective? Check if this is correct. I could be wrong. 5 times 2g by root 3 into r.
Yes, sir.
That's right?
Yes, sir.
Yes, sir.
Okay. Okay. So how do I get this? 5 times g effective times r. How do I get the g effective? This square plus this square under root. G by root 3 whole square plus g square under root, which is nothing but g square by 3 plus g square under root, which is 4g square by 3 under root, which is nothing but 2g by root 3. So 2g by root 3 is the effective acceleration, magnitude of the effective acceleration. Direction is at an angle of 30 degrees with the vertical. Alright, so somewhere here. Asha, now I'm talking about normal reaction. What is the normal reaction over here if it is just looping the loop? I know that normal reaction over here is 0 because it is just looping the loop. Normal reaction over here, let that be n. If I draw the FBD now, n m into g effective 2g by root 3 and acceleration is v naught square by r. Alright, that's the FBD and MAD. Once I have FBD and MAD, I can write force because he's asking force ultimately, right? Whenever he is asking force, you can go for FBD. You have to go for FBD. You cannot, you can go for FBD. You have to go for FBD. FBD and MAD. Once both are clear, I can write the equation now. N minus root 10 gr by 3 root 10 gr by root 3 is equal to mb square by r. N minus 2 mg by root 3. Now that should be equal to mv square by r. What is mv now? V is root of 5 times 2g by root 3 times r mv square by r. So this gets cancelled out. I'll have 10 mg by root 3. Okay. Anything wrong over here? Hmm. Right. Correct. Good. It's going good. Yeah. So 6 mg by root 3 n minus 2 mg by root 3. So n is equal to 12 mg by root 3. See, if you remember, I got the normal reaction, but I could have got it using a shortcut. What is the shortcut? Difference between these two normal reactions is 6 mg, where g is g effective, 2g by root 3, which is 12 mg by root 3. Simply I could have written. Because I know delta n or difference between the two normal reactions. Normal reaction over here is 0, normal reaction over here is n. N minus 0 is equal to 6 mg, g effective. So it's 6m into 2g by root 3, which is 12mg by root 3, which I got same from here. But if at all you don't remember this difference as 6mg, you can go ahead with this. But with practice, you can remember this. See, this is also not that lengthy, but this is even quicker. You can save time from here. All right. Okay. Now, yeah, we haven't done this one. This is a block coming down the incline. This angle of inclination is not given. It is looping the loop here. Radius is r. All right. Distance from here to here is L naught. Coefficient of friction is mu. This height is h. So how do I write the equation now? I know the velocity over here should be root 5g effective times r for it to loop the loop. Now, for it to loop the loop, that means this particle should not stop somewhere here. It should reach this point with some velocity, and that velocity should be minimum, at least this much. That velocity should be more than or equal to this much, greater than or equal to root 5gr. So I know the kinetic energy over that point because I know the velocity, I know kinetic energy. So this is my velocity v naught here. So u is released, u is 0. So energy is mgh minus mu mgl is equal to half m root 5gr whole square. Why am I writing root minus mgl? Because there's a loss due to friction. Initial energy minus loss is equal to remaining kinetic energy. All right. So final energy, what is remaining is initial energy minus loss. So when I deduct the loss, I'll have some energy remaining. That energy is getting converted to kinetic energy. All right. But why am I writing mu mgl? It is independent of this angle. Whether my particle comes from here to here, here to here, or here to here, my friction, work done by friction depends only on the horizontal displacement. If it is a straight line. All right. Note, if that is a straight line, if the track is a straight line, my yeah, where am I? Yeah, if the track is a straight line, my work done by friction depends only on the horizontal displacement of the particle. All right, which is same here, whether this is the case, this is the case, or this is the case, any other case. But from here to here it is L. So it's written minus mu mgl. But why is it minus mu mgl? Friction force is minus mu mg into displacement is L. All right. So is the equation clear? Okay, that's fine. But now let's go ahead with another problem. Let's say I've got a plateau here and then a hill. Downward slope, valley. I've got a spring here. So there's a block. I compress it by delta x from equilibrium position. And this height is, let's say, r. I have to determine delta x such that it should loop the loop. For it to loop the loop, my velocity over here should be root 5gr. So now, if this were horizontal, my delta x would be lesser than this one. Sorry, more than this one. Over here, I am taking the advantage of this slope. Even if I leave a particle from here, there'll be some kinetic energy over here. All I have to do is I have to give an additional push to the particle to the extent that kinetic energy jumps from that particular lower value to this value. And what is the kinetic energy over here? Half m G effective into R. This is my kinetic energy. Alright, so how do you find delta X now? Write the equation, please. Let's go for another interesting problem. After this, we'll go for an interesting problem. So just quickly write the equation. I'm not bothered about the answer. If I take this as my reference level, this is my R. So what is the initial total energy? Half K delta X square plus mgr. Now this is being converted to kinetic energy, which is half m root 5 gr whole square. So I have half K delta X square is equal to this minus this 5 mgr by 2 minus mgr, which is equal to 3 mgr by 2. ఇంతకుముందు 7 mgr by 2 ఉండే, if you remember. So this 2 gets cancelled out by K under root is my delta X. Is the equation clear? Is the equation clear, students?
Yes, sir.
All right. Now let's go for a interesting problem, little difficult one, but very important for all the three exams, NEET, mains, and advanced, because the concept is tricky. Let me tell you what the question is. I've got a pendulum. All right. I've got a pendulum. One end of the string is hinged here at point O. The other bob is kept horizontal like this. All right. Now, if I leave it from here, it goes like this, stops here, comes back, and oscillates like this. If at all, there is no loss of energy. Right. That's what happens. But then, if I have a nail at this point, a nail here at a depth of x, this radius is r, at a depth of x, or length of the string is L, at a depth of x from this point O, there's a nail here. Because of this nail, what happens? This comes here, this comes till here. After this point, it becomes a circle on this one. It moves on this circle now because it's a hinge here. I mean, there's a nail here, there's a peg here. यहाँ तक आएगा and it goes. I don't have a pendulum. I'll show it in the next class. All right, I'll get a pendulum and show it in the next class. It actually happens like that practically also. This bob comes till here in along this arc, but once it reaches here, this will circulate along this arc. This arc. Now the question is, what should be x such that it should loop the loop? Now where should I keep the nail? Where should I nail the nail so that such that when the ball reaches this position, lowermost point, it should loop the loop. So where should I keep the nail? What I do? Yeah, think about it for a minute. What do I do? Now this is x, this radius is r. How much is the radius now? L naught minus x. Do you all agree? L naught minus x is the radius of this circle.
Yes, sir.
Right. Now once that is L naught minus x, velocity over here or speed over here for the particle, minimum speed should be root of 5 times g effective, which is L naught minus x, g effective, which is g here, into r, which is L naught minus x. Now that should be the velocity over there. Minimum speed should be this much for it to loop the loop. But if I take this as my reference level, I write the energy equation from here and here between these 2 points. I'll write mg times L should be equal to half m root of 5g times L naught minus x whole square. So m gets cancelled out. I square it. I'll have gl naught is equal to 5g into L naught minus x by 2. G again gets cancelled out. I'll have 2l here. So L naught minus x is equal to, sorry, 5 into L naught minus x is equal to 2l. 5l naught minus 5x is equal to 2l. 5x is equal to 3l. X is equal to 3l by 5. So I should nail that peg, nail the obstruction, nail the nail here at a distance of 3x by, sorry, 3l naught by 5 for it to loop the loop. If I do it over here, it will not loop the loop. But if I do it over here, it will definitely loop the loop. Because my minimum energy, minimum velocity should be this much. If this radius is decreasing, this velocity is sufficient enough for it to loop the loop. But if radius is increasing, then it will not be sufficient. At this value, it is just looping the loop. Alright, it's not looping the loop with the tension becoming non-zero at the topmost point. Tension is becoming zero at the topmost point when it's just looping the loop. And that is the velocity, that is the position for this one. Any position more than this, if the nail is somewhere here, it will definitely loop the loop. If the nail is somewhere here, definitely loop the loop. Here, loop the loop, loop the loop, loop the loop. Here, it doesn't loop the loop. Here, it doesn't loop the loop. It just oscillate like this and come back, or it will just go till here and fall off. All right, those cases we'll consider later. There is an Olympiad problem based on that, but this is Neet mains level question. All right, any doubts here?
No, sir.
Okay, I'll now frame the question now like this. The question is the same thing, same setup. Is taken along in a car with an acceleration g. Where should this nail be nailed along this angle bisector 45 degrees for it to loop the loop? For it to loop the loop, where should this be nailed? Over here or where? Where should it be nailed for it to loop the loop like this? How do I do in that case? I'm moving with an acceleration g. This car is moving with an acceleration g. So this becomes my vertical. Now my universe is tilted. For it to loop the loop, it should, the velocity over here should be such that root of 5g effective into r. Length is L, this is x. So this is L naught minus x. Now what is g effective? What is g effective in this case, students? G towards left, g downward. So g root 2. 5 times g root 2 times L naught minus x. Half m v square should be equal to initial potential energy. How will I take the potential energy now? I'll take the potential energy like this. Now this is my horizontal now. It's a new horizontal. So my universe is now tilted. So this is my distance from here to here. If this is L, this 45, L minus L cos 45 is my answer. this distance. All right, I'll leave it you with this question. Try to write this right hand side of the equation. Initial potential energy of the particle. How do you write the initial potential energy of the particle is the question. All right. Do you all get the question?
No, sir.
No? Okay. See, this will come till here. Because of the nail, it will loop the loop like this. Right? Now, I have written the right side, kinetic energy part of the equation. Now, this is initial potential energy that is being converted to kinetic energy. And how much is kinetic energy? Half m minimum v square. What is minimum v here? 5g effective, root of 5g effective into r, where r is L naught minus x. So this is understood, right? Now, this part of the equation is what I have to write down. Where it is potential energy, gravitational potential energy, or potential energy in the pseudo force field. My field is now tilted. If it were underground, my gravitational field was downward. But my pseudo gravitational field, which is uh, G effective field, is now tilted at an angle of 45 degrees. So my horizontal is also now tilted now. All I'm asking you to write this equation that write the potential energy of this equation with this as level reference level. If this is my zero reference level, as I go along this one, my potential energy increases. All right. So as I go perpendicular to this one, my potential energy increases. This is my zero reference level. So this level and this level is let's say is h. So I'll have mg effective into h is equal to this much. All I have to write down is h. How do I write down h? L minus L cos 45. You'll get x from here. All right. Is it okay now? Okay. Even if it's not okay, we'll continue in the next class. But this is a good question. Please try to understand this question. Previous question, I'll show it to you, demonstrate and show it to you. All right. When I keep a nail here, I'll demonstrate and show it to you. Give me some time. But then once you understand that, you will have to think about this one that you have got now tilted surfaces are which are horizontal before. My level surface was horizontal. Now my level surface is now tilted. My gravitational field was vertically downward. My G effective field is now at an angle of 45 degrees is the vertical. All right, that's a change and that's a major change. All right, let's stop here, students. You've got a class next, math class coming up. Join the next session.